Hello again, everybody. A new day, a new project. You know, my old say. Remember this one? You know, I use this case for so many projects because I have a transformer inside and the power supply. What I want to do today is to revive, to put again to work one of these amplifiers. You know, it's a mono amplifier. I recovered it from some old parts. Do you remember what I was always saying about recover, recover and recover? And I am the recycle guy, I may say. I never threw away anything. So this board was from amplifier system. It's a classic TDA7294 monolithic integrated circuit. It's supposed to deliver 100 watts on plus minus 40 volts or 42 volts. In between my stuffs I found a new circuit. Unluckily, it was a problem over here. One or two puts, they disappeared. So it was a kind of messy thing, you know, to put these things together again. But anyway, I blamed it on the board because this board was burned before. So I put the new circuit over here. The next challenge is to find me a proper radiator, something like this maybe. I will plant this inside this case with the transformer and make it an amplifier, a mono amplifier, and I'm gonna have the loudspeakers behind here. But the point is now that I have to check how much voltage do I have from the transformer, because this kind of amplifier needs a differential power supply, so it will be a plus minus something. But first of all, let me measure how much voltage do we have here. Power on, alternative current, middle here. Okay, so I have like 16 volts in the other side. Let me see. That's good. 22. So I have plus and minus 22 volts. Perfect. That will make the circuit running, let's say, for maybe 30 watts or something. Anyway, we'll do the test at the end of the things. For now, I have to get rid of some of these wires here because I don't need them anymore. But first I have to check this electrolytics, this capacitors, because I don't like too much this one. It's a little bit bulky, so I have to see if it's nothing happening over there. This one is much better, so I don't know what to say. Two over here, two like this. How to do a very simple differential power supply. How to do that? We have the transformer, okay, so this is the primer, 230 volts AC. Then we have the magnetic core, and that's the secondary. We got the middle here, and that goes to ground, and we have, let's say, 17 volts and 17 volts AC. The middle goes to the ground. Now we have the rectifier bridge here, and that goes to, in my case, in the middle here, those two wires. And of course the other side will have plus and minus. Now we have the capacitor here like this, plus, minus, plus, minus, and from here we're gonna have the ground, and finally we're gonna have minus, let's say 22 volts. Do you see? There's the minus here, and from here we're gonna have plus, let's say 22 volts DC. This is a very simple power supply. I don't want to use any kind of board. It's two together, so minus goes to plus. Be really careful because they are very sensitive for changing the polarity. I have the rectifier here, that's plus, that's minus over here, and all we have to do now is to put the things together. I have to solder them together thanks to my TS100. Okay, and it's always good to have a resistance, or like I'm doing now. There we are. So this is our power supply. Let's make some tests. Minus 21.22, 22. You can even use the AC for LED. This is even better. This will be our pilot. So now I'm pretty sure that we have power over. Now all we have to do is to connect the amplifier to connect the power supply to the amplifier. So all the connections done. All the connections done here. Well, that's the only loudspeaker I have in the house. This is funny, but it's a tweeter. I use it for some other experiments, but we can use it today also. Here, the other one here. Okay. The moment of truth. Power on. No smoke yet. That's good. Is there in? We should hear a sound here. And we have sound. This is great. Nice, it's working. Okay, now let me check the voltages with the power on. 21.7. Perfect. What I want to do is to improvise an 8 ohms loudspeaker, or an 8 ohm. So all I have to do now is to make a resistor like this, and this one here will simulate the loudspeaker. Then we can make some frequency and power test. You see, I have this tool here that's a very low resistance meter, and I have some wire, some special wire like this, that's specially for high temperatures. Hey, we are in the bag. So over here we have, let's measure again. We have 7.7, 111 ohms. Okay, after I make the resistance itself, we're going to measure the impedance too. Okay, so here we have an 8 ohm resistor. That's 8.1 ohm. Let's do another measurement. See, a loudspeaker is not only a resistance. A loudspeaker, it's always an inductor. So that should be okay. Or 8.23 ohms. So I can't see any inductance at all. That's the heatsink we are using for now. Okay, I think it's time for a first test. Okay, power on. So this is the signal path. Let's power on. Yes, it is. Okay, so like I said, it's time for the oscilloscope. Now I'm having a 50 Hertz waveform, and I want to push the volume some more because it feels like it can handle more than this. Let's see. Okay, too much. Well, that's it. So we have maximum voltage 17 volts, minim minus 15, and we have here RMS 11.07. Okay, let's write these things down. Resistance, test 1, 50 Hertz, and we have RMS 11.07 volts. Yeah, we have 1 kilohertz here. Let's see if we can go a little bit closer to see how it's looking. Yeah, it's pretty okay. A little bit of distortion. Okay, so here we go. 2, 1 kilohertz. RMS 10.47. That's for 1 kilohertz. Let me check the temperature. Oh, it's 62 degrees now. Anyway, it needs a better radiator, that's for sure. A better heat sink. Stop for now. Next step, I want to have a 4 ohms. 4.5. Perfect. I have here 20 kilohertz. Then around 10 volts. Okay, now it's getting hot. Pretty hot. Not so hard. 50 degrees. This kind of circuit is working normally to let's say 35 to 40. I think it's 42 volts maximum, and I got here only 17.7 now with this load. If I'm stopping the signal, let's go to 21, and I may say this little transformer, it's hardly keeping the power this circuit needs. So it can be used for different purposes, and it's very easy to install, and you have a lot of fun with this one too. Okay, so all the connections are done, all the wires are in place, everything looks okay here. So up here I have a volume control and the input, and all the connections are done here. Now all I have to do is to put everything back in place, put the screws, get the loudspeaker, and see if it's really working. And here we are, the moment of truth. Let's power on. Yeah, the power it's on. You can see the LED here. Any sound? We'll see in a second, because I have to do a trick. I have to put one of these in here, and yes, we got sound. Feel that? That's perfect. So everything is okay, everything is working as it should. Okay, folks, that's it for today. I had a lot of fun having all these things together, and also having all these tests and measurements. And it's nice to understand how a power amplifier is working and how to use an oscilloscope, a small oscilloscope like DCO138 for measuring power and also currents and voltages and stuff like this. So I hope you enjoy it, and hope to see you soon with some new projects. In the meantime, be safe and please subscribe. Bye bye.